Okay, I'm gonna start recording. There's a high probability that I might mess it up, and I hope I don't swear in this video, because then I have a track that you guys can record it and send it to Miss Camus, and I'll get in trouble. But I will try my best to keep professionalism and be clear about it. Okay. Okay. So we're gonna learn about the cell membrane. Okay. Well, first of all, what is Mr. Kim going to talk about? And as you might have been able to tell, I will upload the PDF document for you guys to annotate. You guys can print it and you guys can write it. But the booklet you got in class, that essentially has everything. I just made my own version of this so you guys can annotate and write while I'm explaining, because not gonna lie, I really don't like that version. Okay. I'm not gonna do it for the entire unit because I think it's a waste of time, but I don't like it. That's the conclusion. Anyways, the cell membrane is a thin, flexible layer that surrounds every cell. It's like a gatekeeper. It separates the inside of the cell from the outside environment and controls what goes in and out. Okay. So essentially what you see over here on the right side, this is like the general like label of it. If you go to higher level, you will see more detailed one, but what you're gonna learn in Science 10 is only what you're gonna be tested on, okay? So in the first place, why are cell membranes important? Because we always talk about it as like the skin of the cell, essentially. The cell membrane maintains equilibrium. If you don't know what equilibrium means, it means to balance inside the cell and then the outside the cell. Okay, so you want to balance them in and out, and I'll talk about that more later on. Okay, so I'm just gonna explain equilibrium over here. So the equilibrium is the cell needs to keep this equilibrium while allowing some substances in and keeping others out. Okay, so it means they want to have certain substances to come into the cell, but they also don't want some substances to get into the cell, right? Because you don't want anything bad to get inside your cell. You want to protect the cell, okay? So our cells, they're called selectively permeable. Permeable really just means that things can pass through. So what it means by selectively permeable is that certain things can go in and certain things cannot go out, right? Because you want to have good people and the bad people out. That's what really means. So I'm just gonna zoom in because I can tell that my writing is getting horrible when zoomed out. The membrane chooses what passes through. Okay. Selectively means like means, well, you guys know what that means. I hope you guys know what this means. It means it picks and chooses permeable means what can go through. Means, yeah, capable of going through. Okay. Okay, so then you are gonna probably be asking, okay, if they're selectively permeable and they want to maintain balance by having equilibrium, what goes in and out? What does Mr. Kim mean when he's saying bad things out and then good things in? Okay, not just bad and good, there's also other things. So the passage of materials through the cell membrane is determined by the size of the molecule, their charge, and whether they're soluble in lipids. Okay, and I'll go explain more in detail. the passage of membrane is determined by the size of the molecule charge, whether they are soluble in lipid. Okay. Now, I cannot use this analogy when I'm in the classroom and Miss Camus is watching. Actually, apparently on Monday, she's not going to be there. I don't know what she's up to, but she won't be there, and I have to be there. I like to think of them as like when you go to a club, when you guys turn 18, okay? When you go to clubs, there's going to be nightclub guards, I should say. They kind of filter some people out because you don't want weird, sketchy people to get into the clubs because you don't want to, ruin the fun of the people. So they kind of maintain it. So I always like to think that these cells are supposed to be like a nightclub guard, letting some party people in, but then leaving some sketchy people out. I like to think of it in that way, but of course I can't really use this analogy because it's talking about clubbing and stuff, and you guys are not 18 yet. So anyways, you guys are watching this video, so you guys can hear this. Okay, so this is essentially your cell membrane. This is what it looks like, okay? Sometimes they call it plasma membrane, okay? It's the same thing. If they say cell membrane, plasma membrane, it's literally the same thing. Also, I do want to mention that I'm going to circle this. So if you look over here, you see these heads, right? And these little tail wiggly things, right? They kind of look like sprouts. They actually move around here, here, and here. They're constantly moving around left and right, okay? They're not always staying in the same place. They move around quite a bit, okay? So this is what the detail of it. So over here, if you look here, you can see that there's the head over here and then the tail wiggling over here. So these are called phospholipid bilayer in another way, okay? So cell membranes is made of, I'm going to use red, phospholipid bilayer with proteins embedded. Okay, you can't see it in this one. What I'm talking about, the proteins embedded over here, is actually talking about this thing over here. These big chunky things are proteins in between your cells, okay? The phospholipid bilayer is talking about the sprout over here, the red, like the sprout thing. So I'll probably write this down. This is talking about this. And the proteins they're talking about the big circular proteins in between, okay? So phospholipid bilayer, bi over here means 2, okay? So it is simply double layer of molecules called phospholipid, okay? Phospholipid is just literally this thing over here. This is your phospholipid, okay? It's just when you have one on the top and when you have one at the bottom, it's 2 layers, okay? Each phospholipid has phosphate head. So the head part over here, I'll just draw it over here. This part, that's your head. And then the lipid tail. Okay, those are your little wiggly tails over here. Okay, this is the top part and this is the bottom part. Okay, now let's talk about the head. So the heads are hydrophilic, which means they like Hydro means water, essentially. Philic means actually to love something. Like, I'm gonna write heart over here, okay? They love water. They want to be with water, okay? So they're made of phosphate group. They face outward towards a watery environment inside and outside the cell. So really what they're saying is the head points to water, and I'll just say water loving. Okay, so if we go back over here, it means that extracellular, these are all water and these are all water. The head part always wants to stay where the water is, okay? Now, unlike the head, the tails don't like water. So again, hydro means water. Phobic means that they don't like it, okay? So I'm going to draw a broken heart. So it's going to be a heart and it's going to be broken, okay? They don't like it. That's why the tail stay inside it, so that the tail doesn't actually touch the water. So we will say that they're actually, you don't need to know this, but they're composed of fatty acid chains. They face inward, okay, away from water. Forming a barrier. Okay. So if you look inside here, I'm going to zoom in over here and use red. All these tails inside this area has basically not a lot of water. Yes, they do pass through. There's significantly less amount of water because they're hydrophobic, whereas the head, these areas have a lot of water, right? So it protects themselves essentially. So you just need to know that the cell's membrane are made of phospholipid bilayer with proteins, which I'm going to talk about soon. And these things are called phospholipid bilayer because there's two of them, one at the top and one at the bottom, so they protect themselves. And the top part is considered the hydrophilic heads. They love water. They want to point towards water. Hydrophobic, they don't like water. They want to stay away from the water. Okay, which form, and because of this forms like a barrier. Okay, so this is the same thing, but just now, it has these proteins around them. These chunky blue things, these are proteins, okay? And I'm not going to talk about the other ones yet. But so you get this hydrophilic head over here, and you got these tail, and these all combined is the phospholipid bilayer, and then you got the proteins embedded to it, okay? This is what I meant when I was talking about proteins embedded, okay? There's proteins in between them. This model that I'm talking about is the fluid mosaic model. Remember how I said these hydrophilic heads and tails constantly move around even when they're together? They're not always like glued together. It's fluid, it moves around, but from the top it kind of looks like a mosaic, like censored if you look at it. I don't know what that really means because I never got to look at it, and I was I don't know. It just doesn't look like it, but they called it the fluid mosaic model, which was made in 1972. Okay, you don't need to know the year. Just know that this is called the fluid mosaic model. It's a mosaic collection, different substance held together by a common material. From above, the cell membrane looks like a mosaic of tiles. I don't really believe in that, but they call it that. I don't, so whatever. The molecules in the bilayer are constantly moving, allowing arrangement of the membrane proteins to change, okay? So this is the basic structure of the cell membrane,